So friends, this is Prof B Oza. Right now I am at Vallabh Vidyanagar, my workplace, where I stayed for 45 years, and I'm enjoying my stay. I've talked about 2 tutorials, and we are in the laboratory environment now. I am very much interested that all engineering colleges in Gujarat, in India, and if possible in world, you see, they should have very good experiments which will teach the students in such a way that whenever they go to field practice, whenever they go to industry, whenever they go for their career, they will be doing their best. They would be knowing the best because they have done hands-on experiments. And these hands-on experiments are very cheap. Say USA, France, all European countries and other countries out of India or other uh, well-developed countries are having good lot much of money. They can spend lakhs of rupees. But unfortunately, in India and in Gujarat, there are many engineering colleges which cannot spend good lot amount. So I am showing the experiments which can be carried out, which can be done at a very low cost. None of my experiment is more than 10 to 20,000 rupees. Or at the most, my friend, 50,000 rupees. 50,000 rupees is not a big thing for any engineering institute, I think so. I worked for 26 years in BVM. I myself received 2 grants, one for 15 lakhs and another for 12 lakhs, 27 lakhs of rupees. And we had very many equipment because I spent the amount with uh, quite a lot much of rather, I mean, economically I have spent the amount so that we have very many number of equipments at BVM, Birla Vishwakarma Mahavidyalaya, and Engineering College at Vallabh Vidyanagar, associated with SP University once upon a time. Then it was affiliated with Gujarat Technological University, and now it is its own university. That means uh, they are they are of their own. So that is BVM. So that is where we have done. I'm working as visiting faculty at Nirma and PDPU also. PDPU is a quite rich institute. They have a power system protection laboratory of 1.5 crores of rupees. But alas, I'm not sure whether the students are making use of that very good laboratory, which has been designed and prepared by a very intelligent professor, Professor Dr. Vivek Pandya. And I am proud because he is my student. And such a good student has designed very nice laboratory. Unfortunately, not properly utilized. According to me, it is underutilized. Anyway, but the institute has a very good laboratory. Nirma also has a good laboratory, but that also, according to me, little underutilized. Very good professor, very intelligent professors, but they need good mentoring, good guidance. I'm trying to do that, and I'm trying to build up a good laboratory at as low cost as possible. So friends, with that, I move to the next slide. I have given my phone numbers. I have given my email ID. Anybody, anywhere in the world are welcome to contact me. I am available. I am retired. No doubt I'm serving once in a week at Nirma University and once in a week at Pandit Dindayal Energy University. But yet, and I'm very busy in preparing these videos, YouTube videos for my sons who have started their own business on EdTech. So, and the name of that EdTech is EdUpMe, as you know. So, but yet you are most welcome to contact me. Next slide. What is the motivation of this experiment? Because any experiment should have some motivation. We should have a feel of understanding that experiment. We should have a zeal. We should have an excitement. We should have a romance of understanding and doing that experiment. The motivation is the power system is an interconnected power system. Simple overcurrent and earth fault relays are useless. We have to use a directional facility in overcurrent and earth fault relays to provide uninterrupted power supply. Therefore, directional feature is a must in overcurrent and earth fault relays. For this purpose, what we'll do, what do we mean by direction? Direction of current with reference to voltage, that is the direction. If the direction of current with reference to voltage is positive, that is, if Vi cos phi is positive, the relay will operate. If Vi cos phi is negative, relay will not operate. Here, the person who has decorated the slides for me, she does not have probably degrees. So it is written that if the angle is less than 900, it is wrong. If the angle is less than 90 degrees plus and more than minus 90 degrees, the relay gives operating signal. Therefore, uh, this is directional relay. If the angle is more than that, that means, so to say, if you say 4 quadrants, then first and 4 quadrants, if I take I as a reference vector and V lying in any of the 4 quadrants, and then if V lies in first or fourth quadrant, then the relay will operate. If it lies in third if it lies in second or third quadrant, the relay will not operate, even though the current is more than plug setting, right? Even though the current is fault current, the relay will not operate, and that is the requirement of directional relay. What is our motivation, or what is our aim? Our aim is to plot the characteristic of that directional relay. Yes, so friends, the aim, an arrowhead aim, we want to plot the characteristic of a directional relay. So theory, as I was telling, I am very much against the theory when we go for practical, no doubt. Today, for the whole time, I will be talking only, so it's a kind of theory. But I had requested in my LinkedIn account, in my Facebook account, that if my viewers, all those viewers who do not just see my video and praise me that yes sir, very good, they have not read at all, they have not gone through the video at all, because they say that we are students, we know everything, you have taught us, but they also need to see, because they had learnt before many years, and I am also new. Whatever I was teaching to them, I am teaching something new today. So everyone, all students should go through the complete video. It will not be more than 30, 35, 40 minutes. They should go through all video. All others who do not know me, all others who are teachers in the institute, all professors who are having 30 to 40 years experience, my dear friend, I am an authority in power system protection. All teachers, even 30, 40 years experience, should go through this video. Everybody in the world should go through this video and then try this experiment, rig up this experiment, and tell me the result. I've given my numbers. If I will get many number of phone, WhatsApps, many number of emails that yes, sir, we have tried. and we have been successfully been able to do the experiment. And now we will be getting it done. We will be making our students to do the experiment, and then students will do the experiment in power system protection lab. Right now, students are just studying. They are not doing any experiment. So, what is our theory? Directional relay is a phase comparator relay. It compares the angle between voltage and current. Its characteristic is a polar characteristic, and it is drawn on Rx plane. The overcurrent relay, we were drawing on IT plane, current versus time. This is the Rx plane, resistance reactance plane. The circuit arrangement shown in the next slide, figure in the next slide, is used to plot the characteristic. This much is only the theory. Friends, this is the circuit diagram. See how many things colleges would have. I think phase shifter colleges should have. What is phase shifter? I got, it's not necessary 450 to 110 volt. You may have 450 to 230 volt. I don't mind. That is not my main point, right? But a phase shifter, a transformer, but it is not a simple transformer. It's a phase shifter. Phase shifter means the primary winding is stationary, but secondary winding, three-phase winding is rotated from 0 to 360 degree, 0 to plus 180 degree, and 0 to minus 180 degree. It can be rotated. You can rotate a voltage vector or a current vector. That is the meaning of a phase shifter. We are using Y-Y connected. The capacity that I had used once upon a time was 1.36 ampere, and therefore I am rotating voltage vector and not a current vector, because my current relay is 5 ampere relay, and when fault occurs, current will be 50 ampere. So I cannot use current to phase shift. I can phase shift the voltage. That would be better. I will keeping current as a reference. What current I am tapping, and I'm using single phase version. You see, because my relays are single phase relays. Three phase relays means three single phase relays. Or even if it is a numerical relay, there are three inputs given. Three inputs for the input transformers are given. You can use any of the inputs, and you can plot the characteristic of a directional relay, numerical relay also. Nothing like electromagnetic, statical, electro or numerical. This is a common experiment. R and Y I am taking. That is single phase. Face-to-face supply I am taking. What I am doing? I am connecting a very large resistance, 170 ohm, 185 ohm, right? So if you just calculate, my resistance goes to 100 and 100, 200 plus 80 plus 70, some 150. So 200, 350 ohms of resistance, 400 volt of supply is there, divided by 350 ohms is just little more than 1 ampere. But my capacity is 2.3 and 1.5 ampere, no problem, right? I'm not passing large current because that is not my wish. I am connecting current coil of the relay at A and B, and I am connecting a 0 to 5 ampere ammeter to measure the current. What I will do? I will use 1 ampere relay, and I will pass 1 ampere through the relay. So rated current I will pass through the relay. Voltage I will vary. What I am doing with the voltage? Once again, I am not taking three phases. I am taking only two phases out of that. Say in this on this single on primary side, whatever voltage I have taken, whatever current I have taken, same voltage I am taking on the secondary side. Voltage, right? Same voltage I am taking. And that voltage I am feeding to auto transformer. Why? Because I want to change the voltage from 0 to maximum. And maximum means 110 volts. Because all the relays have their voltage coil capacity of 110 volts. I am using a DMM because I can measure very small voltage of 0.5 volts, 0.6 volts, 0.7 volts to 110 volts. Therefore, I am using a digital voltmeter. Right. And a X and Y potential coil of the relay I am connecting, and then I will be plotting a characteristic. So if you just see how many things do you have, I think none of the things are not available in your institute. Usually phase shifter is available in the institute. Relay, you want to take the characteristics, so relay has to be available, otherwise you will have to purchase a directional relay. That apart, 170 ohm, 185 ohm rheostats are small things. They are usually available in the laboratory. 5 ampere meter, 0 to 150 volt voltmeter is always available in the laboratory. DMMs are available in the laboratory. Auto transformer, I am not interested in current, you see, because it's a voltage coil. 2 ampere auto transformer, 4 ampere auto transformer is enough. Input 230 volt, output 0 to 270 volt. But here I am not giving 230 volt, I am giving only 110. And from 110 I am varying from 0 to 110. Very easy. I think I don't need any equipment to be purchased in this, my dear friend. 0 rupees, 0 paise. Nothing, no amount. Going to next slide. It is practical description. It is comfortable to shift the phase angle of voltage, as I told you, because the voltage coil takes milliamperes, whereas the current coil will take large current. Relay rating I am using is 1 ampere and 110 volt AC. Auto transformer is used for adjusting the voltage, and voltage is required to be changed from, say, roughly 0.5 volt, because you see the directional sensitivity. Sensitivity means the minimum voltage at which the relay operates is usually 1%. So 110 volt, I need 1.1 volt. So if I can set 1.1 volt, that is enough. But I'm trying to measure from 0.5 to 110 volt. More than enough, right? Minimum voltage will be required at MTA. That is maximum torque angle, or what is known as characteristic angle theta of the relay. If my viewers do not know many of the terminologies, they are most welcome to contact me. I have given my WhatsApp number, I have given everything, and mind well, I am not charging anything for questions. I am not charging anything for answering question. Yes, but if 100 people will come to me to ask question, we will have to manage the time. We will have to mutually agree with the time. You ask me question today and I will answer after 10 days. That is quite possible, because I am 72 years old person, physically getting tired also. Obviously, at 72 years of age, you cannot anticipate this much of energy. So that will happen. But I can dare assure, and many people when asked me questions, I have replied. You are most welcome to ask any question. I am trying to explain in as simple way as possible. What is the equation for the torque for directional relay? Is kVi cos. K is constant. Torque is proportional to Vi cos phi minus theta, where theta is characteristic angle. Why theta? I cannot keep cos phi. If I keep cos phi, theta equal to 0. Theta equal to 0 is not desired, because theta is never 0. When I want the directional relay to operate, I want directional relay to operate when the angle between voltage and current is about 85 degrees. Therefore, I need theta 75 or 85 degree. Usually 90 degree connection I am using. 90 degree, all right. If it is 90 degree and phi is 75, 90 minus 75 is 15. Cos 15 is something like 96%. I am getting 96% of torque. Well, quite good. No problem. But my question is cos phi minus theta. No doubt, I don't mean to say 90 degree. You can adjust 75 degrees also. Numerical relays, you can adjust anywhere from 0 to 360 degree. No problem. Anywhere. Anywhere. Phi is MTA, maximum torque angle. Sorry, theta is MTA, maximum torque angle. Phi is angle between V and I vectors. K is a constant. Right? For all angles between voltage and current, yes, at minimum at maximum torque angle, I need minimum voltage. Maximum torque angle means phi maximum. What is the meaning of maximum torque angle? Phi theta is maximum. Theta is maximum means theta say 90 degree. If phi is 90 degree and theta is 90 degree, cos 0 is equal to 1. That means I will need minimum voltage at that time because cos is maximum. But when phi is less, when the angle differs, then I need little more voltage, right? But some minimum voltage I need. What is that minimum voltage? That minimum voltage is different from relay to relay. If you talk about that old electromechanical relays which are gone, I rather apologize. मैं आपकी माफी चाहता हूँ. I very much apologize. I must not talk about electromagnetic relays. Electromagnetic relays have gone. Aurangzeb was using, Akbar was using, Humayun was using. We are not using. So we should forget about electromechanical relays. But in those electromechanical relays, there was something moving. And when there is something moving, it has to be on a bearing. And whenever there is a bearing, there is a friction. So there is a frictional torque, and you have to compensate for that frictional torque. So you need more torque to overcome that frictional torque. Not only that, but something is moving means something cannot move like that only. Because if some train will pass, some truck will pass, if some vibrations and shocks are there, then the relay will operate. So that the relay does not operate, you have to keep the moving contact little tense by some very tiny spiral spring. So you will have to overcome the torque of that spiral spring also. So that minimum voltage required for the electromechanical relay is large. For static relay, there is nothing moving part. For numerical relay, there are no moving parts. But that does not mean that at V equal to 0, you will operate the relay. V equal to 0, relay will not operate because torque is 0. So no relay has such a possibility that with 0 voltage it will operate. Right? Try to understand. This is the basis for directional relay. Going ahead, what is the practical description? In electromagnetic relay, there is moving cup that I told. Right? Therefore, even in correct direction, even if the direction is correct, relay needs some minimum voltage to compensate for opposing torques. Opposing torques means frictional torques and that spring torque. This region is known as dead zone. Correct direction, but the relay does not operate. Direction is correct, but relay does not operate. That is a dead zone, and that is our problem. That is our difficulty. That is where we have to try. That is where we have to think about. That is where we have to find out some option, find out some remedy. I am not here to talk about all these things right now. For if you want to understand all these things, I have been continuously telling that Adapt Me app is available on Google Play Store free of cost. You can download, and after downloading, you can see what is available there. In that, there are many modules. One part is engineering modules. From engineering modules, there are also many. From there, you have to find out power system protection. In power system protection, right now, there are 3 modules. This is talked about in module number 3. It costs 550 rupees. On YouTube, if you see, 5% discount is given, and you can see everything, all theories, everything better explained. Here it is difficult to explain what can be done about dead zone. What is the remedy for dead zone? That I cannot talk here. So what is the voltage required? Voltage required to make the relay just operative. Just operative. Minimum voltage at MTA is known as directional sensitivity, and usually expressed in percentage of 110 volts rated voltage, my dear friends. Procedure of experiment. What is the procedure of experiment? आप experiment कैसे करेंगे? देखो, पैसे कुछ नहीं, no money. You are not spending any amount. According to me, if you know phase shifter, then I'm sorry, alas, you will have to purchase the phase shifter. If you do not have emitter, alas. But usually engineering colleges do have. What is the procedure? Connect the circuit as per circuit diagram. We have seen the circuit diagram. Switch on the supply and adjust the current to 1 ampere because my relay is 1 ampere. Exact 1 ampere you adjust. Using phase ampere, set the angle equal to MTA. MTA is given by the relay manufacturer. MTA is a design feature. Theta, maximum torque angle or characteristic angle, is a design feature. Relay manufacturer will give. If he says that my MTA is 60 degree, adjust 60 degree. If he says that it is 90 degree, adjust 90 degree. Adjust by phase shifter 90 degree. On phase shifter, degrees are mentioned. You give supply voltage say equal to 20 volt. 20 volt is more than enough because at MTA usually you require 1% of 110 volt. 1.1 is enough, but I am supplying 20 volts using auto transformer. Directional relay must operate at maximum torque angle. Directional relay must operate, but it is quite possible that your CTPT polarity is wrong, and rather than in the operating region, you are in the blocking region. Therefore, if so happens, you will have to change the polarity either of the CT or PT. मतलब बदल दो, direction बदल दो, change the polarity of CT or PT. Now the relay will operate. Okay, done. Now what do you do? Now adjust different angles, start different angles from 0, 1, 2, 3, 4, 5 or 0, 10, 20, 30, 40, 50. Adjust different angles in the phase shifter and increase the voltage from 0. Keep 0. 0, 0 0.1, 0 0.2, 0 0.5, 0 0.6, 1, 1.2, 1.3. When you find that the relay operates, and you will be able to see that the relay operates, no? Because relay operation is seen by naked eye, or there will be some say in static relay, there will be some LED which will light, right? In numerical relay also there will be some LED which will light. And all it will say relay operated on the display panel. There will be something, so you will be able to know that the relay is operated. Note down that voltage at which relay is just operated. So go on changing the angles and find out the minimum voltage. Try to see that you do not extend 110 volts because relay will be damaged. Once you have done that, plot the polar curve. Polar curve means this curve. This is our directional and relay characteristic, right? Angle theta is say 60 degree. I have given, matlab some manufacturer has given me theta is equal to 60 degree. So that line from I axis, reference axis, is known as the maximum torque line. Line to be protected, if you want to say, if line is at 60 degree, line is usually at 75 or 80 degree. But anyway, the zero torque characteristic is what? When voltage is zero. Voltage is zero torque characteristic. So you can see that line, slant line, zero torque line. I will show by my cursor. This is a zero torque line. But this is not a characteristic because at voltage zero relay will never operate. You will need some minimum voltage, and this some minimum voltage in electromechanical relay may be large. In static relay it may be 10% or 20% of that. In numerical relay it may be yet small, but at zero voltage no relay will operate. Try to understand. Therefore this minimum voltage, sorry, this minimum voltage will be there, and this minimum voltage at different angles is different, and that minimum voltage you have to draw a point, join all points. This is the characteristic of the relay. This is the characteristic of directional relay. Beyond that characteristic on this side, is operating zone, and below that is below zero torque line is blocking zone. Relay will not operate. Between this zero torque line and characteristic where the direction is correct, relay should operate, but it is known as dead zone. Relay does not operate, and that is our concern. And that concern is right now a क्या बोलते हैं, it's a suspense. I don't tell now. Somebody who knows well and good, somebody who does not know should ask questions, because everything cannot be told in one thing. Yes, but in my modules it is given. Modules you have to pay. Module number 3 is 550 rupees. You have to pay. 550 rupees is not a big amount. In foreign countries, this is not available. But within a week or two, in foreign countries also, my modules will be available. On Android versions only it is available. It is not available on Apple version. But yes, well, within some time it will be available on Apple versions also. So we want to make this ADAPT-Me, this aptrace universal throughout the world. And we want to pervade. And we will teach many subjects, not only power system protection, but I will surely rather teach you power system protection. Going further, what you have to do, you have to take an observation table, serial number 1, 2, 3, 4, 5, 6, angle 0, 5, 10, 15, 60, 70, whatever, different angle. What is the minimum voltage required at which the relay operates? And then that characteristic. So these are the questions to be answered by you, my dear friends. These are the questions to be answered by you. What do you understand by amplitude comparator and phase comparator relay? I am not answering. You answer if you know well, otherwise you ask me. How value of characteristic angle is decided for a given relay location? Say in my power system, in my Gujarat state, right? There are many power plants. I am at Vallabh Vidyanagar, and at Vallabh Vidyanagar there is a 66 or 132 kV bus. There I want to have a directional relay. So what should be the characteristic angle of that directional relay? How will you decide? What is the equation? What are the methods? How you can calculate that? Explain maximum torque line, maximum torque angle, zero torque line, operating region, blocking region, dead zone. How can you adjust MTA? 30 degree. Dekho jara, this is the software person does not have this degree. Matlab 30 degree, that is superscript, he does not have. 30 degree, 60 degree or 90 degree by CTPT connection. 30 degree, 60 degree and 90 degree, you have not to do anything with relay. You have to do everything with CTPT connections only. So that also I have shown in my modules in my book. My book is available, Power System Protection and Switchgear. I repeat, Power System Protection and Switchgear. The authors are Bhuvanesh Oza, myself, Dr. Nirmal Nair, who is at New Zealand now, a very senior professor, Dr. Rasesh P. Mehta, who is head of the Electrical Engineering Department at BVM Engineering College, Vallabh Vidyanagar, situated in Gujarat, India. Fourth person is Dr. Vijay Makwana, who is very senior professor at G.H. Patel College of Engineering and Technology, a self-financed institute at Vallabh Vidyanagar, Gujarat, India. So all these four are authors, Oza, Nair, Mehta, Makwana. The book is published by McGraw-Hill Education International. It is available in hard version and is available in e-copy also. You can purchase that book. But that book was 2010. In 2010, in my modules, I have added many new things. My modules are 10 times better than book, but then cost. My modules will be 9 or 10 modules will cost about 4,000 rupees. Book is costing 800 rupees. My modules will cost 4,000 rupees. But then you will earn 4 lakhs of rupees of salary, my dear friends. Now it is up to you whether to buy modules or not. Well, anyway, forget about everything. This video is free of cost, no money, no money, and I am teaching free of cost. What is phase advancing? Why 90-degree connection is most applicable? Prepare the specification of a directional relay that very few people know. Prepare the specification of a power transformer. You know how many items are there? There are 40 items for preparation of specification of power transformer. The specification book of power transformer is of 50 pages. Specification of circuit breaker are 30 items. Specification of CT are similarly 40 items. People do not know project engineering. After completing this power system protection, I am going to take the classes on project engineering. I am going to publish the YouTube videos of short videos, 30 minutes, 45 minutes on project engineering. How to specify? How you will specify a directional? I will not answer these questions. Once again, questions continued. Prepare the specification of a directional. What do you understand by the term overreach of an instantaneous overcurrent relay? What do the why do the time delayed relays do not overreach? That was earlier experiment. What is the general practice of setting an instantaneous overcurrent relay for protecting a transmission line? And what can be done in the relay design so that the overreach of the relay is reduced? आप relay design में क्या कर सकते हैं? What can you do? What numerical relay people are doing? I am not answering. Because if I will answer, my authority will be lost, my importance will be lost. But friends, don't worry. If you ask me questions, I will certainly answer. Explain the design features of static and numerical overcurrent relay with the help of relevant diagrams. These are the questions you have to answer. Further question: how does the instant of fault occurrence affects the overreach of an instantaneous overcurrent relay? Out of the two relays located as follows. Dekho, two relays located as follows. Which relay will have more overreach? Which relay will have more overreach? Explain. Relay located in switchyard, it will have more overreach, or relay located in distribution substation, which relay will have more overreach? I am not answering any question, friends. Questions are left to you. This was the practical setup which we developed at Birla Vishwakarma Mahavidyalaya Engineering College. This practical setup is world known now. This figure is available in IEEE Power Delivery section, published in 2005 and quoted by many people. No doubt, I do agree that these are all electromagnetic relays. No, one static relay is there of English Electric. All other, no, second static relay is there. That is DTTM 11. That is also there of English Electric. The old English Electric, now Schneider. Others are electromagnetic relay. But it's not a question of electromagnetic or static relay. You may have a numerical relay here. Characteristic plotting has nothing to do with type of the relay. Try to understand. But this is what we had in Birla Vishwakarma Mahavidyalaya. I want to make my college because I am the student. I studied BE at BVM. I studied ME at BVM. I worked for 26 years at BVM. So my BVM is the best institute. IIT may be very good, but the CEO, the top man, Anil Nayak, right? The best man, very good man, very intelligent person, Anil Nayak of L&T is BVMite. He is mechanical engineer of BVM. So I am proud of BVM and therefore I would want to publish this photograph of BVM. Yes, my BVM. Friends, with that I end with a sentence. I like philosophy, I like spiritualism, and therefore I would want that. And spiritualism is lifestyle. It is not something who is meant for 72 years old people. It is meant for 15 years old people also. It's a questionnaire. A disciple, a student is asking, I want happiness. Everybody wants happiness. Do you not want happiness? Yes, I also want happiness. Everybody wants happiness. So a disciple is asking, I want happiness. So Buddha means a person who is Prabuddha, the person who is enlightened. In India, Buddha means people understand Gautama the Buddha, means the person was the son of Shuddhodana. But he was not the only Buddha. People say that there are 62 Buddhas living right now in body, in world. And I have met at least 5 Buddhas. Fortunate to meet 5 to 6 Buddhas. 5 to 6 enlightened persons have met. So what he answered to I want happiness? First remove I, that is ego. Remove ego. Don't be egoistic. Then, very important, very intelligent sentence. Remove I, then remove want, because it is desire. Buddha said that problem of all unhappiness is desire. मुझको अच्छी पत्नी चाहिए, मिल गई काली. I wanted very good, rather very beautiful woman as a wife, and I did not get beautiful, therefore I am unhappy. I wanted lots of money, lakhs of rupees, but I earned only 1,000, therefore I am unhappy. Want is unhappiness, desire is unhappiness. Remove want, remove I, remove want. Then what is left? What is left is happiness. Pure happiness is left, my dear friend. If you want to be happy, remove I, remove ego, remove desire, then you are always happy. So with this sentence, my dear friends, I once again, every now and then, remind you, hammer on you continuously. Adapt me, don't forget this name, because this adapt me is going to teach you. Adapt me is going to give you all education, online education. Adapt me. उसके साथ बने रहिए. See, go on visiting YouTube. You will be seeing every day new video, and go through that video and you will learn many things. So at India, good night. At USA, good morning. At Dubai, good evening. I don't know. ऐसा नहीं कहते हैं. People tell that namaste, good day, good morning, Sat Sri Akal. So many things. So I thank you once again, friends. Thank you, everybody. Remain with Adapt Me. Aptrace. Thank you all.